concrete is really like a sponge. It just sucks
Sure.
water
Yeah.
very, very slowly. And we designed that cover depth so that water or chlorides don't reach our rebar. But now for the first time with kind of low-cost cameras, we can visualize it, we can quantify it, we can predict the softivity of concrete in a fully automated way. Anybody around the world can do this kind of a test. They all just need to buy 2 cameras and record the video.
Hello, it's Mark Kuhar, editor of Rock Products, and we're reporting live from the AggNexus Digital Innovation Conference. And I'm here with Nishant Garg, the associate professor at the University of Illinois at Urbana-Champaign. Nishant, welcome today.
Yeah, thank you so much, Mark.
Thank you for being here with us.
Yeah.
So, tell me a little bit about your journey. You did work at Princeton, and how did you end up from Princeton as an associate professor at University of Illinois Urbana-Champaign? Talk to me about that journey.
Yeah, sure. So at Princeton, I did my postdoctoral work. So that was about from 2016 to 2018. And before that, actually, I did my PhD in Denmark at Aarhus University. So I wanted to come back to the US because I was here, actually, I did my master's in Iowa State. I'm originally from India. So you can see I've been, traveling all around.
Yes.
And after living for a few years in Denmark, I wanted to come back to the US. So I found a position at Princeton. It was a very good experience. And then that was a postdoctoral position, and I wanted to find a permanent faculty position. And I was very fortunate. There was an opening at University of Illinois, and I got hired as an assistant professor in 2018. And just this summer, I got promoted to an associate.
And your work at the university. Talk a little bit about your research and the work you're doing. But first, how did you get into that field? What interested you that kind of guided you into that field?
Yeah, I think maybe if I go kind of a little bit back, my father worked in a bridge construction company for all his life. So I spent a lot of my childhood, summers watching concrete and watching bridge construction happening. So I kind of, knew that this would be my path. And then when the time came to go to college, my father was like, you have to be a civil engineer. And like a good son, I listened. And, I had the, let's say, the scores and the marks to go to computer science or electronics, but I said, okay, I'll do civil engineering. And I think this is where kind of it started. That was my kind of stream. And then I did my bachelor's in India, and then I wanted to come abroad. I wanted to come to the US due to various reasons. One of the reasons was actually I was also a very big kind of video game player. I really love playing kind of, esports.
Oh, okay.
So I thought in the US, there's actually real
Interesting.
Real interest in real professional gaming. So I would do that, and I will do my master's as well. But turns out, when I started my master's at Iowa State, I also got very, very much interested in research, and research specifically on concrete materials. I was working with my advisor, Professor Kejin Wong. And so I kind of then, put the gaming to a backseat, put the Warcraft to a backseat, but started really working in concrete materials. And from there, I just never looked back. And I've been working now in the field of cement and concrete chemistry for past 15 years.
So what's the latest thing that you're working on? What's kind of your focus of your research, and what direction is that headed?
Yeah, so I think the latest thing, what I'm really, really interested in is now, building low-cost sensors and integrating them with AI to predict the performance of concrete in the matter of few minutes. Right. So, for example, one of the things my group has developed is a patent pending technology this year. If you consider all these supplementary cementitious materials like fly ashes, slag, natural pozzolans, if you have to measure their strength with the strength activity index, it takes about 28 days. We have now developed a new method which can predict that in 5 minutes. Right. So I'm really now excited to kind of take that method forward, because now you can actually do quality control. If you're drying or grinding an SCM, or even if you're receiving an SCM as a concrete producer, you can on the fly predict the quality of it without waiting, for 28 days. It's like waiting for 28 days for me is like, you're checking the parachute after you've landed.
Okay, that never works well.
Right. So that's one that I'm really interested to take forward. The other one, we have been working quite a bit, collaborating with industry. So we have been working with quite a few tech companies for helping them optimize their concrete mixes for data centers. And that almost all of them want to build their data center yesterday, right? So we've been working quite a bit with Meta. and we recently collaborated on their data center in Rosemount, Minnesota. So this was about 700,000 square feet in size. It's really massive. And we collaborated with Meta and Amrise to use a open source AI model to optimize their concrete mixes across multiple dimensions, right? Which is performance, cost, speed, and sustainability. So when you have to optimize across many such dimensions, and you have hundreds and hundreds of mixes, turns out AI can do it really, really well. And the other really thing that makes you passionate about this, the AI is completely open source, right? So anybody can go online, download it, use it. They don't have to pay anything. So that's something, another interesting thing I've been working on.
Now, going back to the project you talked to before then, the sensors are actually embedded in the concrete, and the concrete is giving you information then as it ages. Is that what the goal is?
So the sensor that I talked about, first one, which can predict the, let's say, the reactivity of the supplementary cementitious materials. The idea there is it's a new test that we have developed, right? We do it in the lab, and the idea would be to develop an automated prototype or device. It was imagine a box where you put 1 gram of fly ash or 1 gram of SCM, and then in 5 minutes, it tells you how good or bad or what's the quality of that material. And once you know that, my hope is then you can really optimize how much cement replacement you can do. And you can cut down on that over design that we heard about earlier this morning, about this 80, 90 pounds per cubic yard. You can really cut it down because now you finally know, because SCM is the biggest variable component in the entire concrete mixed proportion. So if you can really narrow that down, that can really be a game changer. Now, for the SCM producer, it also could be very, very helpful. For example, somebody's producing, let's say, calcined clays somewhere in the world. They want to do real-time QC. Every 5 minutes, they can optimize their process conditions, which is their calcination, their residence time, the amount of grinding, to make sure they sell a consistent product.
In terms of gathering the data that would be delivered from these projects, who would be responsible for aggregating the data? Would it be the producer that's actually doing the mix? Would somebody be coming in to do that for them? How do you see that working?
Yeah, I think the actual implementation side of this, we are still kind of thinking about it, because I would be kind of very honest here, right? I'm an academic in a university, and this would be kind of, let's say, our first step foray into the industrial world or the entrepreneurial world. But my thinking there is that if we have a desktop device, almost like a lab equipment, wherever it is placed, whether it's at a concrete plant or a SCM producer's plant or an independent third-party testing lab, the owner of that equipment, as they use it, the data will be aggregated there, and then it will go and be stored on the cloud, so that over time, also as more and more data is collected, we can apply an AI algorithm to further improve the prediction of it, because now we are predicting again 4 weeks in advance.
So at the end of the day, when we push this out further, what's going to be the benefit to the concrete producer?
Yeah, I think the biggest benefit I can see is that they can be much more confident about what's the SCM replacement level they can do with the particular kind of SCM they have in their area. And if the SCM source changes for them overnight, they can quickly pick that up and on the fly adjust the cement and the fly ash or any other SCM levels, and be really precise in their strengths.
So where in the past they might have relied on a standard recipe or maybe somebody's professional and personal opinion about how that should change, right now we're using data to really narrow that down.
Exactly. And then that data point, then you put in some sort of an AI model, which also now many startups and many companies are promoting. Then that data point makes that AI model much more stronger in predicting the entire strength curve, with very high confidence, with very low error bars. And then if a mix is 4,000 psi, then they don't need to over design.
Can the data be take into account the degradation of rebar within it, if it's that kind of construction?
Yeah, so I think if you think about from a durability point of view, there's another new test method that my group has come up with last year. So if you consider most of the concrete durability testing is either done with this, RCPT method, or now there's also this resistivity based method that has been around. And those methods are good. However, there are some issues regarding making some assumptions regarding what's the compositions or the ionic compositions in that system. So what we have come up with is a computer vision method where you take a concrete cylinder and you expose it to water at the bottom face, and you put cameras on the side, and you simply observe and quantify how the water is going into the concrete. Right? Essentially, concrete is really like a sponge, right? It just
Sure.
sucks water
Yeah.
very, very slowly. And we decide that cover depth so that water or chlorides don't reach our rebar, right? But now for the first time with kind of low-cost cameras, we can visualize it, we can quantify it, and we can predict the sorptivity of concrete in a fully automated way, right? And the benefit here is, these cameras we actually bought from Amazon for $30. So anybody around the world can do this kind of a test. They all just need to buy 2 cameras and record the video.
You may have been asked this question before by somebody, and if not, you've probably thought about it. How did the ancient Romans and Greeks make concrete that seems to have lasted thousands of years, and we can't seem to make it last, 20 years in some cases?
Yeah, I think that's an interesting question.
They had no sensors, by the way, but
Right.
they managed to do it.
Yeah, I think that's an interesting question that keeps coming up, and I see that sometimes there's some popular news outlets talk about it, and there's even sometimes research about it. So I would say I'm not an expert on the Roman concrete. There are people out there, but I would say what my understanding of that topic is that there's a couple of things. I mean, first is, of course, we don't know the whole truth. We can't go back in time, but what we can do is we can look at what facts we have, right? So one thing is that they did not have much of reinforcement in that concrete, right? So reinforced concrete by principle, most of the failure is coming from the reinforcement, right? When it corrodes. So if you eliminate that, you have a long lasting structure, right? But of course the con of that is you can't build multi-story structures. You can't build taller structures. So that's one. So there's no reinforcement in Roman concrete. Second, there is also the question of workmanship, right? I mean, Romans did have access to let's say very, very good and motivated and cheap labor, which we heard about this morning, right? There's a labor shortage here, and so we can't really compete with the labor of that time. And then third, there is now some emerging research which is talking about certain kind of materials that the Romans used, and the Roman cement was fundamentally different from the Portland cement that we use. We use a hydraulic cement, which can essentially set underwater because of this alite phase. The Roman cement is really relying on this pozzolanic reaction. They had these volcanic ashes. And by the way, if anybody has not seen them, it was worth visiting Italy and seeing. I visited Mount Etna in Sicily 2 years ago, and I saw the mountains of ash, right? If you have that in your neighborhood, it is just silly not to use it, right? It's like free reactive material. So they relied on, and that lime and pozzolanic reaction is fundamentally different, right? It can't work today because it is too slow, okay? The strength gain is very, very slow. But it worked in that time because at that time they had not discovered clinkering. And there is some emerging research that says maybe that is a contributing factor to long-term durability. I think it's still an open question. So I would, the third part I'm a little not confident on, but the first two, no reinforcement, good workmanship, are some of the reasons I would attribute. And there's some, there could be some survivor bias here.
Yes, very much so. Didn't some of the isn't one of the end results of the combination of materials they use? Didn't they create almost a self-healing concrete that if there was a crack, the crack sealed themselves?
Yes, I've heard about that. I think there's some research recently come out on that. And again, that's some really emerging recent research. We as academics and practitioners have to really dig more to really answer that question. But I would say that, again, we have a lot of nostalgia. A lot of people have nostalgia for the Roman concrete, the good old times. But the concrete we have today is way, way superior to that what we had, thousands of years ago. The modern Portland cement with high amount of alite, there's nothing better than that which have been used in history.
Interesting. So, in terms of future research, I mean, what do you have kicking around in your head? What else would you like to get into? What do you see out there that would require a little bit more research and take the interest of your time?
Yeah. I think, I think this is a very good question, right? Because all of us have very limited time, right? We work for 30, 40 years. And
Sure.
I'm always thinking, what are the problems worth pursuing? And that's what I tell my students, that let's spend most of the time finding good problem. Solution comes next. So I think looking forward, one thing I do see is that, all the things that are happening right now, I think there is an abundance of low cost sensors and AI, and some of these machine learning models off the shelf are now so good, and we should really thank the tech industry, right, who has built them, developed them. We're just going to adopt them. So using those for concrete problems is just basically open ground, right? So some of the things I'm very excited about is, can we predict other concrete properties on the durability side? Can we predict ASR, alkali silica reaction, the concrete cancer, again, painful testing, several weeks. Can we predict that in a matter of few minutes, right? That would help aggregate producers to figure out what's a bad aggregate, what's a good aggregate, what's the aggregate rating, right? Shrinkage, again, painful testing, you're just simply measuring how the bar is shrinking, right? You're waiting for several weeks. Can we predict that in a few minutes using AI? Because if we can speed these things up, we really change the future of civilization. Because I fundamentally believe time is money, and time is greater than money, right? There's no shortage of resources on our planet, in our solar system, on our galaxy, right? We have plenty of minerals and metals in our universe to mine. It's really a question of how and when we mine them, right? We can build all the Dyson spheres to get all the energy we need around all the stars. There's no shortage of materials, but there is a shortage of time for each human being, right? Unless we crack immortality at some point. But I think that's not feasible at this
I'm sure somebody's working on that.
Oh yeah, I'm sure there's people, there's companies, startups, talking about taking the lifespan to 150.
Yeah. Well, I've read some of those. Yeah.
Yeah. So I'm really interested in speeding up the testing time. Maybe I'm a little impatient, but I think we, in 21st century, in 2025, we don't need to wait 3 months for one data point.
Excellent point. So, in terms of the AggNexus Digital Innovation Conference, what brings you here? What special thing are you looking to get out of this?
Yeah, so I think here my friends at Ultrabiota invited me to come here, and I was very much happy to come and talk about some of the work we have been doing in particle packing. They told me it's a very aggregate heavy conference, so we've been looking at measuring both size and shape of these aggregates, and this is what I'm going to talk about tomorrow. And again, our idea here was, I worked with a student, and we didn't have a lot of money for that project, so I had a $200 optical microscope in my basement. So I told my student, why don't you just go and spend your time on that microscope and see what you can do? And he spent an year, and he came up with this very nice thing called the particle shape metric. He measures sand aggregates, sand particles, like hundreds and hundreds of them. And turns out this single shape metric, very simple, can predict multiple properties of concrete. It can predict the workability, the strength, the durability. So
Wow.
it's not just size, shape also matters.
Yeah.
Right? So I came here to talk about that, but then when I look at this conference, I think I feel like I'm the only academic here. 99% is industry. So I'm really looking forward to learn from industry leaders, what are their priorities? What are their challenges?
Yeah.
Because I don't want to be in this kind of ivory tower where we write these fundamental papers, but it doesn't really help industry. So I want to make sure we do work. It helps society move forward as we train the next generation of workforce to work for the industry.
Very interesting. Well, we appreciate you taking a little time to talk to us on the podcast, and good luck with the rest of the show. And thanks for being here.
Yeah, thank you so much,
Thank
Mark.
you.
Yeah, thank you.